Welcome to this station, the Pythagorean Theorem, where we're going to actually take and reduce the stress level for students when they hear the Pythagorean Theorem, because we're going to replace it with some really great positive energy, active participation, and fun activity that will help build conceptual understanding of what the Pythagorean Theorem is. And that's the whole point of the EBPs, is to actually actively engage the students so that they can retrieve that information later on as they encounter the Pythagorean theorem. So let's begin with the basics. What is the Pythagorean theorem? A squared plus b squared equals c squared. I'm just going to show you a little visual real quick through these next few slides, and then we're going to get into you creating just a baggie and fill it with the appropriate amount, 25. And you can then take that back to your team and show them how to use this. If you choose to use the template that has the Starburst template, then see about having students bring in or donating some Starburst so that you can do this activity, and then they can go home with a nice sweet treat after they can finish that activity. Otherwise, if you want to use the tiles, the 1-inch tile, you can do that as well. So let's begin. So here's the crux of it. Being able to identify that this is a right triangle because this is a 90-degree angle here, and that attached to the right triangle, attached to the right angle are adjacent angles, and they are, in fact, the legs of the right triangle. Opposite the right angle is the hypotenuse. So this is considered A, B, and C. A, B, and C. And what it's saying is the area that can be formed on this side of the right triangle, one of the legs, added to the area formed by the other leg. When you add them together, their sum will equal the area that would actually be created if you built a square, a beautiful, perfect square on the side of the hypotenuse. Very simple. So let's just look at this. Students need to prove this. They need to be convinced. So here's what we've got. The A is 4 units. The B is 3 units. When we create squares, we have areas of 16 and areas of 9. They're saying that if you combine these two, then what will happen? You will, in fact, see that, yes, it is a 5 by 5 square. And so the sum of those areas. And then, like students, they want to do it again and they want to try it again. So we're going to give you a couple different options. But remember, we want to begin with the tiles, or we want to begin with this concrete approach, and then students can move to a more semi-concrete using maybe graph paper. Let's begin with the demonstration now. Well, here we have it. Today, we're going to take this Pythagorean theorem, which states a squared plus b squared equals c squared, using a right triangle, and we're going to use some other visual supports. Now, I have two different ones here, and I have one that's on pink cardstock and one that's on white cardstock, and the difference really is that this is designed to use with 1-inch tile squares, where this one, don't want to let you know yet, but this one has been is designed specifically to use with, wait, oh yeah, some fun and exciting starbursts. So again, we're going to be using the starburst activity, but as students are building this, maybe individually or with partners, then they'll want to come together and join their forces with their starburst. Otherwise, you'll be poor buying all the starbursts that are needed to do maybe even a larger triangle. Okay, so it's a front back, and you can put groups in larger groups to discover the larger one, or you can divide it up and have each student work on an individual one. Now keep in mind that this activity is going to be very tactile. It's more in that concrete part of the CSA, concrete, semi-concrete, abstract instructional sequence. The next phase would be then, after they have lots of experience with their starburst or their 1-inch tile squares, we can also then move to graph paper. Here are 2 triangles that are also right triangles. They're both 3-4 triangles, they're just in different orientations. And so we can then help build this relationship. They can actually draw it out and then start building. They'll have to start by identifying the right angle within this triangle, and then from there build out the squares that build, and that's why this is b squared, the area of a square with a side length of b. The area is going to be b squared. The area of a square with a side length of a is a squared. So they can count it. They can actually identify the length of each one of these sides. So this is our b, which is 3, and our a, which is 4, and try to determine this. Now that's where we're also going to be building out a square off of the side C. And this is really difficult on graph paper for students to actually draw. It's there is a knack to it and lots of experience, and some students get it and some students don't. So the nice piece is that they can build this square later on by just estimating the area, the size of it, but they'll conceptually understand that it's true that a squared plus b squared is in fact c squared because they've had this experience, this demonstration. So the first thing you're going to do is you're going to grab your white cardstock paper from this station, and you're going to then identify this is the side length with 1, 2, 3. Now what you're going to do is then you're going to grab some of your starburst, and we're going to just simply build a square. Yes, building a square by just lining them up. And now if we build the same thing on the other side, we have a side length of 4 for our a squared over here. And if we build a square, knowing that it's the same properties, that we're going to then build a square with side lengths of 4. So each side has 4 on it. Now if we tighten this up really nice and neat, and I'm doing this with one hand because I'm operating the camera with the other hand. Yes, this is my homemade video. We have created this relationship. Now, we now have a square built on one side with an area of 16 and another square that has a side length of 3 with an area of 9. Now, the Pythagorean theorem states that if I combine both of these areas, that's adding a squared plus b squared, I will get the area that will form over here, and that will be equal to this combined area. And so what we're going to do here is we're just going to pause for a second. I'm going to build the triangle, or build from the triangle, a square that will be out here that consists of these two areas. So by the power of magic, you won't have to watch me build this. So we're going to pause for a second and we'll be right back. Voila, here we are. Now I've intentionally positioned them so that you can see the color coding. You can actually see the 9 from this side here embedded in here, and then you should be able to then see it 1, 2, 3, 4, 5, and they are 1, 2, 3, 4, 5. So now we have a 5 by 5 square, and if you count them individually, you will get 25, or this is the c squared. So the area of the side A added to the area from side B, so that's a squared, that's the area, plus b squared, this area, equals the area on C, which is c squared. And we have now conceptually proven this. So then students should be able to actually create these, but I would give them more opportunities to experience this. And if they still struggle with this, then have them work on graph paper as well, and then have the opportunity for them to pull out some square tiles and use some graph paper and go back and forth during this instructional sequence, and eventually this will help them solidify this relationship. My next step would then be, if I have c squared and I have if I know this one, could I determine this side length? And that is where we would want students to start hypothesizing how could they determine a side length if given c squared or given c and given b. Could they do it if they were given a and determine b? So exciting stuff. Create demonstrations and visual supports to support our students.